Hi, welcome to the day two of the Agentic AI, right? So actually, we are building a lot of things, and we are going to build together, few more things, or maybe 100 more things on Agentic AI. Okay, this is not just about what is Agentic AI and what all this doing, right? You also you're also going to learn a lot of the demonstrations and libraries and for agentic AI implementation for each and every algorithm in AI, what is going to happen and how we have to understand the agentic AI process, right? So in each and every places, wherever you are using basic machine learning or advanced machine learning, like deep learning and other processes, right? So you will get to know, where would be the process of agentic AI has been implemented. So wherever you are seeing, I mean, yesterday itself, we have seen some of the definitions about agentic AI, right? So what are we going to do today? So we'll just see the history of agentic AI. It's almost equivalent to the history of artificial intelligence, but the start of agentic AI, it is very important to know as a developer, right? It is really, uh, information that you should know, or each and every developer, AI developer, or machine learning developer, or machine learning engineer should know, you know, what to follow and what not to follow. If you know the history of agentic AI process, then you are free to go. And for each and everything, if you lay down the foundations well, then you don't have any kind of a challenges. And even though if you face any challenges in future, right, you will be able to solve or resolve by yourself. Okay, so let's dive into the second day, and also thank you so much for the warm welcome and warm reception of the agentic AI process, the 100-day challenge of the agentic AI, the demonstrations or product implementation, whatever you call it is, that is up to you. Okay, so really, I'm really grateful for the wonderful receptions, and also keep learning, and even I'm also learning, right, by implementing so many things, and you also learning along with me. Okay, uh, thank you so much, and we are diving into the informations. Okay, so I hope you are viewing my screen, all right, and right. Okay, see the process of uh, let's take down the defined systems blog for the information what has been shared for today, the day two. Okay, and then we'll start the one of the AI, I mean the agentic AI implementation. For one implementation will be same thing. Okay, so what does the history says? We'll just read some of the informations because it is very essential to know the history. If you just see the picture, if you just observe this image, okay, the evolution and also the process of AI process when it has been started, and what would be the luxury what we are into now, and wherever possible it has been changed, even the rules has been changed, even the implementation process has been changed, right? It is an interesting image, and I got this through ChatGPT itself, um, and it is really nice depict of the history of agentic AI. Okay, so how it is. See, the birth of AI agents, started around 1950s and also 1960s, right? In between these decade, right? I think after 60, there are so many decade has been passed, right? But the rule and the other phases, all right, the agentic AI phases has really been implemented, 60 years back. It is really 60 or 70 years back, I would say, right? So the idea of creating machines capable of simulating intelligent behavior dates back to the 50s when pioneers like Alan Turing and John McCarthy, these two people, they after these started testing, laid the foundations for modern AI. So it's already been put into the mathematical and statistical numbers, and then it has been changed into the automation process. Okay, so how the theory, how the concept, and how the research has been happened, right? So the concept of an agent in AI began as a way to describe systems that could autonomously execute actions based on predefined rules. Okay, now we are talking about predefined or pre-trained models. Okay, the GPT. GPT, the PT is PT stands for pre-trained models. So millions and millions of text, even billions and billions of text has been trained to get into the process. Right now, the benchmark has been set while we got the introduction of ChatGPT in 2022, right? They just launched the product of virtual agent of text to text model. Okay, the text model has been trained almost 176 billion text. 1 billion is equal to 100 crores. Just imagine 176 billion text has been trained on. Okay. So for anything you wanted to implement as an agentic AI, or you wanted to create any kind of a simulated process of AI agent, that is an autonomous process, then you have to do the predefined or pre-trained model. Okay, that is very very important. Okay, so the rest of the thing you just go and just read. I don't want to bore you. Just read through. And just go to my blog, deepmindsystems.tech, and you can find the day two of the today's process about history of agentic AI. Okay. See, what my point is, why I just started this. I wanted to tell you this concept. Okay, what is that concept? Actually, ELISA in 1966, developed by Joseph, was one of the earliest conversational AI agents. Now we are seeing the evolution from AWS product called Alexa, right? The pioneer one was ELISA. ELISA is also a conversational chatbot. Conversational AI has been built. Just imagine this is how wonderful the day and age. 1966 itself, one of the products has been built, right? And that too, it's a simulated human-like conversation using simple pattern matching. Okay, so simple pattern matching and rule-based scripts. So Elisa could act like a therapist by reflecting users' statements. Though it had no real understanding of language, but it still respond to the users. This is what I wanted to tell you. Like if you see the data, the sample data, right? The user says that I feel sad today. Immediately, Elisa will be responding, why do you feel sad today? Okay. So it is just taking the conversation to the next level, but still it is independent. Okay. The expert system, it has been built through some kind of a trained model. Now, if you just ask Alexa any questions, play songs, I mean, maximum in our culture, we use Alexa product as a speaker, right? You ask, I mean, multiple times or so many times, or by default, you ask Alexa to play. But Alexa has the capability of, or capable of doing lot of other processes as well. Just go and explore it, or we will just do some kind of a video in some time back, maybe after this, the completion of 100 days challenge, right? So just imagine. So wherever you are you are just trying to interact, all right, through any kind of a device. It is just interacting like a human being. It is not just a machine. It is not just a robot. It has some kind of a, I mean, it will be talking to you like, um, wherever it has to give the stress to the words, and also wherever it has to give some pressure on the words, right? So it will be understanding the importance of words. Sometimes it will not, but it is trying to, trying to give some the emotions. That is what I'm trying to say. The sentiments, the emotions through each words. Maybe if you ask to play a romantic song, if I mean Alexa product, it is not trying to get you what you are asking, then what it will say, I'm sorry. Okay, if you just closely watch the conversation by Alexa, that means what I'm trying to say. If you closely, trying to understand the pressure of words and also the pleasure of words, just see whether it has been very close to human in nature, or it is still, it is a the improvised mission language. Just close. I mean, I will leave it up to you. Just closely watch. Okay, right? This is the base now, and what we are going to do, what we are going to implement as an agentic AI. Let's come on to the process of implementing a thermostat. Okay, so it is like how you are controlling the temperature in your home. Still this kind of an the smart home has not built in our house, but still consider your remote. You are operating AC through your remote, and now you will be connecting those kind of features into Alexa. If you just built if you just built around the connect your uh, I mean AC into your Alexa product, then you'll be controlling through voice messages. Okay. Now, a similar way you can control the light, right? And also you can control any kind of home appliances like refrigerator, washing machines. And only thing is, it has to be connected with the Wi-Fi. Okay, all the devices. So all the devices has to be connected under Wi-Fi, one Wi-Fi. Then you can control through voice messages. Likewise, I mean, in broad countries like US or any countries, if you take in, they, through voice itself, they can increase the temperature of the home or decrease the temperature of the home. Okay, maybe through a summer, they will increase or decrease, the temperature of AC, right? And if it is not, if it is very cold, then it is a heater, right? It's a dry, with the air, it is just passing through. Then you will be able to control. Again, will be able to increase and decrease. So this is what we are going to implement today. So considering the fact that you will be already knowing this environment, if not, maybe we'll be creating another lesson, right? If you are very new, but still you are able to understand what I'm talking, because it is very, very simple and in simple English, and you will be able to understand, or just wait for my another videos for entire this kind of an introduction. So this specific audience I'm considering, maybe they know Python environment, they know libraries, how to use the libraries, and then I'm just getting into the uh, what we are going to do. I'm just going to create an agent to control the temperature. Okay, so the name is thermostat agent. So I'm using NumPy and also the matplotlib for getting the uh, visualization. Okay, so visualization like this. Okay, so for this kind of a visualization, I'm just using the okay, matplot, and also coming to the figure, the plotting results, and then we're just using the um, how the x-axis and the y-axis and everything. Okay, so what I'm going to do? what is really happening. Okay, if you see the class variable, right? I'm just declaring the thermostat environment. Okay, starting the temperature in, this is in degree Celsius, 22 degree. Okay, and also the outside temperature might be the 15 degree Celsius. So even from this itself, you might be knowing that it is not for the Indian context. This is for maybe the US context. Okay, no worries. Anyway, we are going to develop this. Okay, the temperature 22, the target temperature 22, and the outside temperature we assume that 15, and I mean how the energy calculation has been set up. Okay, next we are defining the I mean def in Python. Okay, and then this is the self and also into action. So action. Okay, so what I'm going to do right now, we will be getting or discussing each and every part through your virtual assistants, like cloud environment. So cloud is really a nice environment, so that you'll be see the learning curve for how to create an agentic AI. It is nothing but you don't have to interrupt in between. There should not be any or minimal human intervention. That process should be a agentic AI, and you are creating or you are in the process of creating agent. That is one. The second is, once you decided to create an kind of an AI assistant or a AI agent, then you have to use the specific library with respect to your problem statement. Here, the problem statement is, imagine you are teaching a smart thermostat to control the temperature in your home. So this is what our code is doing, but with the computer program, because instead of the physical device, right, we are controlling through the software, the through program. So what it is going to do, the first and foremost thing, thermostat environment class. We are creating an environment class. So this is like a virtual room with a thermostat, and it keeps track of the current temperature, desired temperature, and outside temperature. This is what the code is doing. Okay, current temperature and outside temperature. Then what it is doing, when you will tell it to heat or cool, it changes the temperature and uses some energy. If you start assigning some kind of a thing, then that is the point of consuming the energy or emitting the energy. Okay, now you have to put some smartness. Okay, now I'm going to define or ask you, what is smart? Okay, now we are talking about controlling your smart home. So wherever you are able to, wherever you are, if you are able to control through Wi-Fi or internet, right, to control the entire house, maybe the not only the temperature, you can control your the other devices which are connected to your this common device, maybe through take it for granted Alexa product. If you have installed Alexa product at your home, through this smart device, you are making your home to be a smart home. Okay, so why the word is called as smart? There is no human intervention between this process. That is why it is called as smartness. Okay. Uh, Now, the smart controller, this is the brain of a smart thermostat. So it learns over time what actions you have to control, maybe heat or cool or do nothing. Okay, or best in different situations. So it has a cheat sheet that is called as Q table, where it writes down how good each action is for different temperatures. Okay, so let's explain this. Okay, this step is nothing but it is trying to write some temperature and energy cost. Okay, and temperature zero point 0.5 and the energy cost 1.0 or 1.0. Okay, the natural temperature change based on outside temperature. Maybe consider if you are sitting in the AC room, right? In the AC, you can see that inside temperature you will be able to see. The outside temperature, maybe some of the other devices, very smart, small devices, you will be able to see outside temperature. This based on that you have to change or modify your inside temperature. Okay, so that is why this code has been given. So based on the natural temperature change based on the outside temperature. Now calculate a reward. Okay, this is if you are trying to learn about a reward or punishment. Okay, there is a concept called as reinforcement learning. Okay, this is what we are going to learn today. Okay, so this is a starting point. So what is a reward? Okay, so first we will just describe the code environment, and then I will come to the reinforcement learning and how it has been implemented and how it is just getting some reward or punishment during the process of algorithm. Okay, so this reward is nothing but temperature difference. If it is temperature difference, just see the explanation of the code, right? So we let the smart controller play with the thermostat for many days. First, you have to make sure that training is happening or already happened. Okay. Each day, it tries to keep the room comfortable while using as little energy as possible. And also, every time it makes a decision, it looks at how well it did and updates its cheat sheet. So now in real time, we need to create a database. Okay, so without data, you can't train this model. And if you can't train this model, then prediction won't be effective. Then prediction won't be effective. Then what is the use of this model? Right? So to make it more effective, you have to do some kind of a training in the loop. Okay, it should be a continuous process. So for that, that is why the Q table has been put in place. That is called as cheat sheet, and it is every day. It is just trying to record the temperature, minimum, maximum, heat, or cold, cool, or whatever it is. Right? This is for the training purposes. If without this training purposes, the testing process won't be happening. Okay. And then the results and how we are plotting this result. After all the learning, we look at how well the controller did. We draw graphs to see if the temperature stayed close to what we wanted and how much energy was used. Testing this smartness and agent, that means test the trained agent. Now the word has been put how the agent will be acting. So until training is happening, there will not be any agents has been created. That means for to have the agentic AI process should be in control, then your model should depend on the trained data. Okay. That means if you are asking Alexa for any questions, okay, so tell me about what is a artificial intelligence. If you are asking this question, then Alexa would have trained before for multiple times or multiple phrases, because every individual will be asking in a different pattern of question. But the thing is, what is what is artificial intelligence? That's what it would be. So the machine, the inside smartness, the inside the machine of artificial intelligence, it has to respond back to your question based on the phrases. Okay, so I'll come to the point later, maybe because we are going to deal with 100 days, right? So each and every time we'll be taking one kind of a algorithm and we'll be discussing. And that is called as one smartness what we are going to build. Almost around 80, 85 smartness we are going to build. right? And that is called as agentic AI process. And if you collectively see a product, then the product would be, used by the larger audience and multiple people coming into place, right? Then you will be, I mean, that product would be a biggest product, a bigger product. Then we should be able to run those things under um, cloud server, and then we need to operate for a bigger audience. Okay, let's see this. So this thermostat agent we are going to have, we are going to create after the training has happened. Now we have to test that trained agent. Finally, we put our smart controller to the test. We start with a warm room and see how well it can cool it down to the temperature we want. So we draw another graph to see how it performs over a whole day. So this is the basic process, how the temperature has been controlled automatically. There is no human intervention. Believe me or trust me. Okay, there should not be any because if you just ask control, I mean, if you just ask Alexa, please control, I mean, or please control the temperature to 30. Okay, it will just do. You are not doing physically. If you're not doing taking the remote and do the human, no, nothing. Just asking through words, just through your voice. You are controlling the entire system, controlling the smart home. Okay, here it is. The process is called as reinforcement learning. This is the algorithm and famous algorithm, right? I will tell you how this algorithm is working. For instance, you are, I think yesterday, the previous video, if I told you, don't worry. If you are trying to install a chess game for the first time in your mobile or in your laptop, okay, for the first time, there is a possibility of winning against the computer, right? Is more. The chance of you winning against the computer is more. First time. Okay. From the second time onwards, you will not be able to beat the computer. So what does it mean? Actually, this process is called as reinforcement learning. That means it is learning by mistakes. What is the mistake the computer was doing? First, it will try to read and accept the defeat. That means it is getting punished. That is what I was telling, right? Reward and punishment. It is, punishing by just, giving me the chance of winning the game for the first time. What does it mean? Punishing means it is trying to read my behavior and attitude. If I just play the chess game against the computer, for each step, it is trying to analyze my movement, what I am doing, what I will be doing for the second time, third time, fourth time, fifth time, and sixth time, and go on. Right? For the that is why if you are smart or if you are okay playing chess game, try now. Okay. Again, just observe what would be the success rate. First time, 90% or 95%, you will be able to win. That means the computer algorithm, it is trying to learn by, happening the mistakes, and it is just, giving you some of the information, it is giving you the reward. Maybe a very traditional movie or, masala movie, right? The commercial movies, the hero, for the first 3 or 4 times, he will be beaten up by the villain, right? That what does it mean? Okay, he wants to know how well trained the opposite person. So, so psychologically, I mean, we are dealing the psychology too. Reinforcement learning, it is nothing but a pure psychology. Okay, it is trying to read the human. I mean, the system, the machine is trying to read the human. Even if you are just taking your a chat GPT, just see, it is trying to, if you see the history, right? It is nothing but your, what it is. It is all about your characteristics. It is defined, the definition of characteristics. And also, if you see the cloud environment, if you see the my history, then it is based on, it is trying to understand how my search, I mean, how my question is. What are the questions I'm asking? It is trying to understand my behavior. Okay. Likewise, the reinforcement learning, right? It is trying to understand each and every steps. And from the second time onwards, like the movie, the same kind of a movie, right? Only the hero will win. Here, the hero would be your smartness. That is, reinforcement learning algorithm is your hero. Okay. And you never, I mean, it is very, very impossible to win. And you have to, think like a machine. And that's how, very genius person like Vishwanathan Anand and Pragyananda, I mean, Gyananda, I mean, there are so many people who are coming up now. They will be thinking ahead of, the steps. If the opposite person is, thinking of one time, then these guys will be thinking maybe 10x or 15x or 20x. It depends on the opposite person. Okay. So that is a reinforcement learning, right? This is like a training a dog. So when the thermostat does something good, keeps the temperature right while saving energy, it gets a treat. That means a reward, the positive reward. When it does something bad, it gets a small punishment, the negative reward. So over time, it learns to do more good things and fewer bad things. Okay. So yes, of course, it will be doing both the things, but most often it will be doing good things. So exploration versus exploitation. Sometimes the controller tries random actions to see if there is a better way to do things. Other times it uses what it has learned, right, to make the best decision it knows. So in each and every algorithm, in each and every agents, the decision making is very important. What is the decision making? If you're asking question to agents like Alexa, right, it has to respond to your expectations. If it is not like that, then you won't use that kind of a device, right? So now you just compare the exploration and exploitation. Okay. And sometimes if your expectations is not fulfilled by the agent, this kind of an agent will be asking the questions in what way. Or I mean, sometimes if you're asking to play some songs and that library doesn't have, and the agent, I mean the Alexa, will be responding back to you, sorry, right now I don't have this, song in my library. What else I need to do? What kind of other songs I need to play? Do I need to play a random song, or do I need to play different songs? Please let me know. So that is how the system, right, the getting reinforced to tell those kind of things. Okay, the state and action. The state is like looking at a thermometer and seeing the current temperature. The action is deciding whether to heat, cool, or do nothing based on what it sees. And then cue learning. This is the specific method our controller uses to learn. It's like filling out a giant scorecard for every possible situation and action. So in simple terms, we are teaching a computer program to be a smart thermostat. That is nothing but we are building an agentic AI, autonomous process, by letting it practice controlling a virtual room's temperature thousands of times. It learns from its mistakes and successes and gradually becoming better at keeping the room comfortable while saving energy. Okay, so this is what this code is doing, and I will share this code in our, uh, you know, um, maybe in a blog, maybe in the YouTube channel, in this same recording, right? And just go and enjoy. seeing the results, right? How would be the training loop is happening, and how many times, how many iterations. Iteration is very important in each and every training loop. Okay, so in a range of 24 hours in a day, and how this agent is getting into action, right? And how in each and every action, each and every next state, how would be the rewards and also the punishment, right? And this is very simple loop. The for loop has been, getting trained on with each temperatures and also the energy cost. Please, take, it is very, very simple process, simple controller, right? It is very simple code as well, right? So whoever knows the Python code, it knows better. And whoever is very, very new, you have to try learn the Python. Maybe, after you join the course, after you join my course, maybe this is the business pitch again. If you just, join my course, then you will be getting the real-time experience of how you will be able to learn Python and also how we have to implement this code. Okay. So don't forget about the learning algorithm. Reinforcement learning algorithm is mostly and widely used algorithm because that is how many processes, many applications, will be done. Okay. So I hope you enjoyed, and also just to see this graph, visually, and also you'll be able to see the temperature control over 24 hours and how it has happened, and what would be the target temperature and what would be the actual temperature. And it is, actually, I mean, our mind, how our brain is working, and based on that, how the reinforcement learning is working. In a similar way, we will be, controlling, or we will be building the agentic AI product, or at least a simple, smart, one-time task agents will be able to build like this. Okay. I hope you enjoyed this, second day of agentic AI process, and thank you so much, and see you soon. Okay.